Welcome back from lunch. We could not have had a better speaker to kickstart our post-lunch discussions. Dr. Siddhartha Mukherjee's work includes some of the most interesting issues we face today, and his research and contribution to the field of medicine has earned many accolades. His book, The Emperor of All Maladies, A Biography of Cancer, won the Pulitzer Prize in 2011. His latest book, The Gene, An Intimate History, is the story of the quest to decipher the master code of instructions that makes and defines humans. We are extremely delighted to host today Dr. Siddhartha Mukherjee to talk about the new paradigms of cancer therapy in India. Dr. Mukherjee.
Thank you very much. This is a great honor to give this talk. I want to focus a little bit about, most of my work is on the front lines of cancer therapy. So I want to focus a little bit about what we're doing in these front lines and how they might be applicable to wider contexts, including India. A lot is changing in cancer therapy. So there'll be some technical things we'll talk about, but of course the central message is how to bring these therapies to India. I will talk a little bit about some historical context so that you can understand how and why we ended up in this particular place today. The high-level summary is that we are beginning to understand cancer at a cellular and molecular level, and this understanding has highlighted the enormous diversity of individual cancers. This is something that has emerged out of genetic sequencing of cancers, and of course out of the understanding of physiology of individual cancers. Because of this diversity, we have been forced to think about precision medicine or precision on partially individualized therapies. And that's a huge challenge, because if we are to deliver precision medicine or partially individualized therapies to not just one patient, but hundreds of thousands of patients, the question of how to do this in a manner where the number of patients is so large is actually a huge question. And this is something we are trying to grapple with as a community of researchers. And we also know that one theme that's emerged from the last decade or so of research is that early treatment is likely to bring benefits. So these general ideas have converged on, I would say, 2 or 3 essential principles that we are going to try to deploy in the next new, I would call, say, the next new century of cancer treatment. One is that detecting early and treating precisely are likely to be themes in the medical future of cancer. Given the diversity of cancer, it is now becoming extraordinarily clear that prevention efforts must be doubled, and we have to figure out how to deploy them in countries like India and other places. And as we do this particular effort, and I have to emphasize this last point because it is among the newest things that we are learning in cancer, particular effort must be placed on host factors that might control cancer. And by that I mean that for the longest time we've thought about cancer as an abstraction, as cells growing in a petri dish. More and more we're realizing that the host, that is the human being who actually is the victim of cancer, the human being who's carrying the disease, is just as important in this equation as of course understanding the cancer itself. And there's a yin-yang kind of situation and interaction. So in order to direct therapies against cancer. There are other examples of this. We'll talk about things such as CAR-Ts, which are, again, new technological mechanisms which use host factors, host T cells, host immune cells to attack and attack the cancer. So in some ways, fundamentally speaking, it is as if we had focused somewhat monomaniacally on the cancer itself. And of course, there are important things about that. The genetics of the cancer is extraordinarily important. But to understand who the other side of the equation, the genetics of the genomics of the host, the physiology of the host, the physiology of the patient has come about just as importantly in the new era of cancer therapy. I'll be focusing a lot on that, this idea in particular. And this again is this illustration of the yin and the yang. We have understood a lot about the cancer cell. We're focusing a lot more on cancer itself. Some brief words about history and cause, because we need to understand how this came about. Cancer is a very old disease, one of the oldest diseases known to humans. The technology is new, but the disease is old. This is probably the very first document that we own as humans, a medical document that we own as humans, called the Edwin Smith Papyrus. And there is a case description of breast cancer in the middle of that papyrus. And of course, in that time, there was no real known treatment. The word cancer comes years later, decades later, centuries later. This is Galen, who supposedly the physician who supposedly coined the term cancer. The term cancer comes, of course, from the word, the same as the word crab. And somehow the idea was that the tumor buried under the skin with all the blood vessels around it signaled something about, looked like the crab or resembled the crab. This is a metaphor that remained, it was called karkinos. The metaphor remained across multiple centuries and remains the word that we use today. But the question of the cause, what caused this disease, was of course left, there were 1,000 theories long before we began to understand what the theory was. And the first real understanding, or the first real foray into understanding the cause, was made by pathophysiologists such as Rudolf Virchow, who began to argue that the fundamental cause of cancer was the dysregulated growth of cells. I don't know if you ever had the chance to go to Virchow's museum or his archives in Berlin. I've been. It's an extraordinary place. Virchow collected specimens of lung cancer and breast cancer and other kinds of cancers, and using microscopy was able to look at them down the microscope and make the astonishing claim at that time, a radical claim, that regardless of the tissue of origin, whether it was brain, whether it was breast, whether it was breast cancer that had metastasized to the brain, in other words, had even changed the original site, at the source of all of these cancers was the malignant or inappropriate proliferation of cells. Cells were dividing when they should not be dividing. And Virchow also made the claim that cells, the cancer cells, had to arise through a corruption of normal cells, that there was some corruption of normalcy that allowed a cancer cell to arise. He didn't know what that corruption was, how a normal cell would convert into a cancer cell, but that process was loosely called transformation. Something about the physiology of the cell became transformed such that a normal cell knows, as you know, knows when to stop growing, but cancer cells don't know how to stop growing. A particular example that I often give my own graduate students when they come to rotate in my laboratory, I ask them, if you cut yourself with a pinprick or something, why is it that you don't grow a new hand? This is actually a very fundamental and important question. Why is it that you don't, every time you cut yourself, you don't start growing new limbs or a new face? And the answer is we still don't fully understand, but the basic idea is that normal cells, when a wound heals, it knows when to stop healing as well. There are genetic directions present within cells that act as accelerators and brakes of growth. And so just like a car can accelerate and brake and stop at the right time, a normal cell can accelerate its division and stop its division at the right time. Cancer cells are cells where that process has been disrupted. And the question then became, what disrupts that process? What is the fundamental reason that that process is disrupted? And that wouldn't be solved for another 100 years. And it would bring together many, many researchers. I won't name all of them. But most importantly, the idea is that at the center of all of these things were genes that control normal cellular growth. So you could inherit a mutated version of that gene. This is a picture of Hilario de Juvia, who was a Brazilian ophthalmologist who noted that cancer ran in families and therefore genes had to be involved. This is a picture of Percival Pott, the surgeon who made the observation that foreign chemicals, such as smoke or chimney soot, could also cause mutations in genes. You can get mutations from chance, and here's Peyton Rouse, who in the 1900s also suggested that viruses, because they can alter cellular DNA, can also cause mutations. So the center of all of this puzzle, how could there be four different factors all converge on the same idea? And the idea is that every cell in the body has genes that allow that cell to control growth. And if you mutate those genes, if you change or corrupt the DNA code of those genes through a variety of mechanisms, you can either inherit the mutation, you can inherit the mutation, you can corrupt it because of a chemical reason, it can be corrupted because of chance. Just when cells replicate, they can make a replication error, they can make an error in copying and thereby corrupt the DNA. And of course, through viruses, you can begin to now unleash the process that causes cancer. That brought us up to the 1990s, but since then, we've actually learned a great deal more about these genes and their relationship with the body and how they can be technologically altered. So the question then became, how many genes were there? Is it 1 gene, 10 genes, 100 genes? Is it different between cancers? Is there one master gene? Or are there different genetic variants between different cancers? Is everyone with me so far? Yes, great. So this became a very central question, and this, of course, is a question that starts motivating therapy. So around the world, researchers started wondering about how many genes there were and how they differ from one cancer to the next. And the answer turned out to be very surprising, and this was work done really through a rather broad international coalition of researchers as we began to sequence cancer genomes. I'm a hematologist. We did this work in leukemia. Others contributed this work from colorectal cancer, brain cancer, lung cancer, and we began to compile all this data and ask the question, how many genes cause cancer and how they differ from one cancer to the next? Now, I'm not going to go to the specific genes because they're not that important, but to give you a schematic, let me show you this. So let's talk about, for instance, breast cancer, but this could be true for any other cancer. You can imagine the entire human genome as a blank sheet of paper with the first gene on the top side and then like a snake going all the way to the bottom right. And you can ask the question, which of course we were able to do because of gene sequencing technologies, what were the mutations in this individual breast cancer? And just for an example, let's say that there were 8 mutated genes. I have displayed them as a schematic. Now here's the point. A second woman now comes to your clinic, also has breast cancer, looks exactly the same, is classified exactly the same way, staged the same way, everything looks identical, but if you look at her genetic fingerprint, the genes that are mutated in this second woman's cancer, they're somewhat different. And this is the third woman who, same story, third woman with breast cancer, let's say the same stage, same cancer, looks exactly the same under the microscope, but genetically speaking, this cancer is different. There are obviously some genes that are common between these, and then some that are unique. This is an extremely important point because it highlights the fact that every single specimen of cancer is its own unique specimen of cancer. Some cancers, not only that, within a particular tumor, we now know that in one person's tumor, there are cells that are genetically heterogeneous. So there may be 100 odd types or 100 or 150 odd cell types present in one single tumor. We've done this work actually most beautifully in blood cancers such as leukemia, showing that within a single person's leukemia, there may be 100 subtypes growing at different rates, competing with each other to take over the bone marrow in that case. And sometimes they can have 100 mutations, 120, 130 mutations. Sometimes there are fewer. They come in all different types in terms of the kinds of mutations that are experienced. So this was very, in some ways, this was, I would say, a very sobering thought for us because the question then became, if every cancer is its own specimen of cancer, how on earth can we possibly treat this disease? Because the diversity would be of such phenomenal quantity that we would be really stumped in our capacity to deliver medicines. But nonetheless, we did begin to focus on mutations that ran across multiple cancers, and particularly mutations that drove the biology of the disease. This is a picture actually of actual data from the same. If you take this last plot, and if you were to take all these individual maps and you were to summarize them together, you would get a landscape map with the most frequent mutations being represented by big dots, big peaks, the less frequent ones with small peaks, and of course individual ones represented by individual dots. And here again you see the level of diversity of cancers. Nonetheless, by the 2000s, we began to focus on trying to find therapies not directed against typically directed against things that we thought were likely to be common driver events in cancer, or events that allowed these mutations to communicate with each other and thereby change the physiology of the cell and make it divide more rapidly. And you can imagine this, again, as a very complex machine in which, normally speaking, the machine functions with its various subparts functioning, but now these subparts have been corrupted so that one part is moving autonomously. And in a simple-minded way, you could think that the first attempts, the early attempts from the 1950s of giving chemotherapy, was like throwing a big rock at this machine. You took a big boulder and you threw it at the machine. And so a lot of the effort in terms of what happened since the 2000s has been to find particular vulnerabilities in this mechanical apparatus within this genetic network that will stop the division without really throwing, as I said, throwing a rock at the machine. Because if you try to stop cellular growth in general, all the normal cells that are also growing in the body will also be affected. And you very rapidly reach a toxic threshold in which you can't drive any further drugs because of you can no longer give the drugs anymore. So much of the effort has been focused on on finding the right medicines. So now that, of course, brings us to the question of treatment. The original attempts, before we understood, this is from the 1890s, before we understood the mechanism which was driving the cancer cell, the simplest way to treat cancer was to cut it out. So this is a picture of William Stewart Halsted, who, of course, advanced the famous Halsted mastectomy to try to remove the tumor and try to remove as much of the tumor as possible. And since that time, since the 1950s, we began to also envisage what we now have started calling classical chemotherapy. This is Sidney Farber. This is one of the first patients ever treated with chemotherapy for childhood leukemia. And in fact, even though it was quite as I said, a rock thrown at the machine, these were quite successful treatments in some cancers. There was spectacular data in childhood leukemias. In fact, this remains the mainstay of treatment for childhood leukemia. Childhood leukemia, ALL in particular, is a disease where we moved from the 1950s from 100% mortality to about 10-15% mortality. So an 85 to 90% change in mortality rates in that disease based on combination chemotherapy alone, using drugs that would kill cells rapidly. Similar effects in breast cancers, lymphomas, and testicular cancers. But the problem, as I said, is that they were toxic drugs, often poorly tolerated that target cellular growth, and very soon you reached a toxic threshold with these drugs. So then the question, as we advanced the idea of understanding the genetic basis of cancer, we began to think about targeting growth more, or targeting the cancer cell more acutely by finding particular vulnerabilities within the cancer cell, and again, like shutting off single parts of the machine rather than throwing a rock at the whole machine. And these led to the inventions of the first targeted therapies. This is Barbara Bradfield. She's actually an important figure in the history of cancer. She's the first patient to receive Herceptin for metastatic breast cancer, and surprisingly was, in fact, had the best response in that first pivotal trial and is still alive today, 16, 18 years after the invention of that drug. But of course, this was based on the idea that her tumor had to have the mutation that conferred the vulnerability to Herceptin. If it was not HER2 positive, she would not be responsive. So there was a matching between the genetic fingerprint of the tumor, the driving mutations in her tumor, and the fact that she would respond to the medicine. This is from that pivotal trial, and of course shows that patients without Herceptin had a short survival, only 20 months, whereas with Herceptin they had a very rapid survival. And we also learned very soon after that if you used Herceptin and drugs like Herceptin, these targeted therapies, much less toxic usually, although still they have toxicities, much less toxic if you used it with in the early setting rather than in the late setting. By early, I mean before the tumor had metastasized. If you could find a tumor, detect it early, for instance, through mammography, then you'd get very, very promising results. This is from, again, a pivotal trial from 2005 that shows that if a woman with the early breast cancer detected now, for instance, through mammography, had surgery, radiation, some chemotherapy, followed by Herceptin therapy, if the tumor had that marker, could have a 91% survival at 5 years. This is actually a remarkable number. In other words, 91% of women who now receive this combination therapy, including targeted therapy, have the capacity to live at 5 years, now up to 10 years. It's a real remarkable moment in history, in human history and medical history, because these women 10 years, 20 years ago would be dying of metastases to their brain, metastases to their spine and other parts of the bones. This was really difficult to treat disease. So HER2-positive breast cancer has really transformed, much like childhood leukemia has transformed during our lifetimes. And highlighted the theme that if you detect early, if you personalize, and if you use targeted therapy. I'll talk about immunotherapy towards the end of this presentation. So then the question becomes, so we talked about personalization and targeted therapy. The question becomes, how are we doing some of this? So I'll show you some of the newer data that's emerging from our lab and other labs. One thing that we've been able to do is, of course, use genetics, the genomics. Just like I showed you, if you are able to sequence a cancer, you may be able to find the particular mutations. And if you find the particular mutations and are lucky enough to have a drug that can stop the growth or the signaling from that mutation, that's very successful. So that's using the genetics or the genomics to drive therapy, personalized therapy. Another way we've been focusing on is sometimes, in fact, that's very hard to do. So we use functional testing. This is stuff that's coming out from our own lab and from other labs. And in fact, actually is quite easily scalable. These are 5 different patients. This is from my own laboratory, 5 different patients where we took the tumors out of the patients and we cultured them in these so-called organoids. These organoids really recapitulate the cancer. They have host factors in them, host cells in them growing in tandem with the cancer cells. They look like tiny little nodules of cancer. And they can only be cultivated in the presence of certain factors. It took about 10 years for us and others to identify these factors. All 5 of these are colorectal cancer. You can do this for head and neck cancer. You can do this for most epithelial cancers. You can do it for lung cancer. And what's nice about it is that once you establish this culture, this organoid culture, is you can screen drugs on them as well as do the genomics. So you can do the gene sequencing on these, try to find the vulnerabilities based on gene sequencing. At the same time, you can test up to 700 drugs. We have automated this using a robotic system. And this is, again, what it looks like. Here's a single cancer now tested against, not all 700 are present. Not all 700 drugs are present. But here's a single cancer in which we've tested. This is SE0150. This actually happens to be a young woman, 45-year-old woman with colorectal cancer, metastatic to the peritoneum, in which we've tested now 750, going up to 2,000 drugs. What's interesting about it is that we have a system of scoring. I won't go through the details of the system of how we score, but you find a highly active set of drugs over here. Noticeably, they are not standard chemotherapeutics. They're all targeted therapies, and they're drugs that are investigational. Some of them are already available, et cetera, et cetera. Importantly, we cannot thus far get information from the genome to be able to predict this. This is unique to the organoid. Somehow the organoid is capturing some feature of the cancer that the genome itself is not being able to predict. We are now using artificial intelligence and AI-based algorithms to predict, to understand how this might be related to the genome. Here's a second example. I'll show you how different they are. Similar, again, same cancer, colorectal cancer. Compare the first one, 45-year-old woman. This is a 62-year-old man with colorectal cancer, also as an organoid. Completely different drug spectrum, actually. and pulling up drugs that are quite different from the first one. And we are going to treat the second patient now with drugs that are predicted by these organoids. This is another example of the same thing. This is one drug now looking across 5 patients, highly sensitive, insensitive, insensitive, highly sensitive, insensitive. So you start this, you can begin to almost use a kind of fingerprint. This is a functional fingerprinting of cancers. This is now becoming, we are robotizing it through a company that I founded in Seattle. And the trial is called the Apollo trial. It's a multi-institutional trial. It'll launch in Australia, in Seattle, and we're hoping in India as well, because we now have the capability of growing this. Actually, head and neck cancer grows extremely well. It's one of the best growers in this system. So that's one example. I'll talk a little bit about what we're doing in detection next. So of course, many of you know the standard mechanisms of detection. Those involve testing, mammography, colonoscopy, and some blood tests such as the PSA test, not a good test, but at least an average test for cancer, early detection of cancer. But we have moved on since then in detection as well. So one thing that we're doing is, of course, rather than focusing on just visually looking at things like mammography, we're trying to use genetics. So trying to find genes that increase risk, trying to find within this population, again, who are likely to have a highest quartiles of risk, and use them in screening programs that are more intensive. So that, along with to find states that increase risk, and by states I mean things like obesity, inflammatory states, co-infection with certain pathogens, is particularly important in India, infection with viruses, or other cofactors that may increase risk. And of course, multiplexing that with finding early signs of cancer using biopsies in the blood, or using non-invasive biopsies that find earliest signs of cancer long before they can be detected visually by instruments such as mammography. And of course, these are multiplex. They're interrelated to each other. So rather than just using the standard mechanism, you went to your doctor, they asked you some questions about your history, exposure, and loosely about heredity, we're really arming ourselves to finding a much deeper ways of asking questions about history, exposure, and heredity. I'll give you a couple of examples of that. And the main problem here is that we were very reliant on trying to find carcinogens. And there's no doubt that in countries like India, there's vast numbers of carcinogens. You can imagine tobacco smoke is still among the most major carcinogens that's present in this country. Viruses like human papillomavirus are carcinogenic viruses prevalent in this country. So there's a long way to go just to handle those carcinogens. The problem is that beyond those carcinogens, since the 1990s, we have really struggled to find human carcinogens that are chemical, removable, and have high numerical impact. This is a very controversial statement. This is a statement that we are really trying to really assess and understand whether there are more, there are large numbers after the ones that we've already identified that are chemical removable and have high numerical impact. There are certainly many that we found, but they usually don't have the numerical impact as the ones that I discussed before, such as tobacco, or in the case of countries like India, human papillomavirus and others. So we've moved really to thinking about risk states, such as obesity, genetics, inflammation, etc. So I'll give you a little bit of a kind of a view of how the genetics might work. So one thing that we're doing, it's a very large project. It began in the UK, is now being widened, is to create a kind of learning table in which, now that we can sequence genomes of individuals, you can on one axis put multiple genomes, and on the other axis put all sorts of biometric data such as height, weight, cancer risk. Of course, this has to be done very carefully. It has to be anonymized. It has to be centralized, because the only way to do this properly is to have not just tens, not hundreds, but hundreds of thousands of genomes and hundreds of thousands of individual biometric data. And then you can ask algorithms, either simple algorithms or complex algorithms. I won't go through the simple or the complex algorithms, to use this information to try to assess who has the highest risk of cancer. Can you use the genetic information to predict or understand future cancer risk and thereby allow these people to be screened more effectively? And in fact, you can. These are the first data from this. This is from a preprint that just appeared in which you can do this for breast cancer. So in breast cancer, remember the old method was to use mammography, very loosely use history. But now that we have all of this genetic information, you can take genomes and take tens of thousands of women and group them into risk quartiles. Here's a typical risk quartile. As you can imagine, it's a Gaussian curve. Most women will have standard risk. What is interesting is, we'll talk about this right at the end, there'll be women with much lower risk, and most importantly, there'll be women with much higher risk. This is women who do not know that they have a risk of breast cancer, but their genomes are predicting that they have a high risk of breast cancer. In this case, their risk of breast cancer is about 8 to 10-fold higher than the rest of the population. And it's based on not one gene, not two genes, but often on hundreds or perhaps thousands of genetic variations, genetic loci that are in their genomes. So if you practically think about what this would mean to this audience, it would mean in future that you would be able to assign women in this audience a quartile of risk long before you had any signs of breast cancer. And those with the highest risk, we would do something to. We don't know exactly what that something would be, but we would do something to those women to try to identify their risk even better. And this is a new way of thinking, really. It has been empowered by the genome. I'm going to skip, so this is what we're doing in terms of risk. I'm going to skip quite a few slides ahead because I'm going to finish up and talk about the last piece, which is using the host factors now to understand cancer. So bear with me as I skip some slides ahead. This is, again, other detection mechanisms of cancers. I want to reserve a few minutes towards the end on using host factors such as T cells to prevent or to use against cancer. So everyone has thought or heard about this word CAR T cells for malignancies. What are CAR T cells and how do we use them? To understand what a CAR T cell is, we have to understand how the immune system recognizes cancers. One way that the immune system could, in principle, recognize a cancer is that antigens in the from the tumor cell, here's a tumor cell in cartoon, antigens are presented on a complex of proteins called the MHC and presented as a peptide complex. They are presented to the immune system to survey, and a T cell comes and recognizes this complex, hopefully that this is something that's unique to the tumor cell, and it signals down and then activates itself and then ultimately kills the tumor cell. So this is the classical paradigm by which T cells would attack and kill a tumor cell provided it has a foreign antigen. And again, you can think about this as a tumor cell presenting a kind of flag. Most tumor cells don't do this. This is one of the main problems. But occasionally you can have tumor cells that have antigens that are presented. T cells recognize them using a complex, signal and activate themselves. And the purpose of this T cell, of course, is an immune cell. And some of these T cells can kill these tumor cells. A CAR T cell takes this idea and makes it, uses bioengineering to re-engineer the T cell. So now, rather than hoping for a tumor antigen presented on a MHC, you can recognize the antigen itself. You don't require it to be presented in this manner on the MHC. And interestingly, what you can do is you can take all of this complex and create a gene that takes all the elements of this complex and combines them into a single domain. In other words, the activation and the recognition, all these signals are basically combined into a single domain. So this would be the antibody. You don't need to know the names, but this is CD3 zeta, another gene called CD28. And one way to think about this is that the body has a multiple safeguard system to make sure the T cell gets activated only under the right circumstances. So in other words, it uses one signal from the T cell receptor, a second signal from CD3 zeta, and a third signal from CD28. That's to prevent T cells from becoming overactive and causing all sorts of autoimmune diseases. In a CAR T cell, you've taken all of these three signals, signal 1, signal 2, et cetera, you've combined them all into one molecule, so that that molecule is extremely powerful, and once it activates, it can really activate this T cell and allow it to kill the antigen. The problem is that these are not easy to make. It's a complicated manufacturing process. I'll spare you the details. There are now several in clinic in the United States. The cost, this is a surprising number, take this number into consideration, per infusion is $417,000 per patient. Now the question is, can this be delivered to patients at a cost that is 1/10 the cost, perhaps 1/20 the cost, and we can ask the question how to do this in the context of a country where, of course, $470,000 is an absurd number. The number, even in the United States, this number begins to beg absurdity in terms of the cost per patient. The manufacturing cost in the United States, we make these. I make these in the lab. The manufacturing cost in the United States, if you make them under GMP, under good manufacturing practice, is about $30,000 per dose, for us at least. And the question is if you can bring this down, like we did computers, if you can bring this down by a factor of 100 or perhaps 1,000-fold using various new technologies, including robotics. But of course, they are successful. This is the first patient to receive one of these products. She's still alive today in relapsed refractory ALL. And as you know, we are now making variations on this. Again, I will spare you all the details, but we are making variations of this technology to allow us to do this in various patients at much less cost. And we're trying to use this along with other technologies such as antibodies that will break the barriers to making these cells reactive to the immune system. So I will stop here because this is just a vignette of how we are combining host factors, genetic factors, early detection, and prevention in trying to create a new milieu or a new ecosystem around cancer. The major issues remain production, cost, and how we deploy them in large populations. But if there's one central message here, is that for us, the landscape of cancer therapy is evolving rapidly, combining both the genomics of cancer, which we have a more and more detailed analysis of, and now using other important features such as early detection, early prevention, and understanding host physiology to try to change the therapeutic paradigm for cancer. How this is to be applied to India, how it will now move in areas remains a challenge, not only for us technologically, but also in terms of labor and cost. And those are things that we will address in the next panel. Thank you very much.
Thank you, Dr. Mukherjee, for such an interesting talk. To join Dr. Mukherjee on stage, I would now like to welcome Ms. Kiran Mazumdar-Shaw, Biocon, Satyajit Mayor, National Center for Biological Sciences, Sarv Saravanan, Dell EMC Corporation, and Navneet Kapoor, AP Moller-Maersk, for our next panel on reimagining the innovative ecosystem role of public and private institutions.
Good afternoon, everyone. Can you hear me at the back? Can you hear me at the back now? Okay. Well, one of the challenges of having a session right after lunch is keeping the audience engaged. So the good news is we have a stellar star cast here for you, so it makes my job easier. You already heard the names of the panelists, and I will talk a little bit more about them in a minute. But we have an interesting topic in front of us. We're going to talk about reimagining innovation ecosystems and the role of public and private partnerships in that. But let me just introduce the panel a little bit more in detail because it's worth celebrating their accomplishments. My first panelist needs no introduction in India or anywhere around the world, but like I said, worth celebrating her numerous accomplishments every time we have her with us. Kiran Mazumdar-Shaw is the chairperson and managing director of Biocon. She's been named in Time Magazine's 100 most influential people in the world, Forbes' world's 100 most powerful women, and Fortune's top 25 most powerful women in Asia Pacific, and the list goes on and on. Kiran's passionate about making healthcare affordable and is committed to developing drugs that can benefit billions. And she's one of the few Indians, perhaps, and the first woman signatory to the Gates Foundation's Giving Pledge, committing to donate a majority of her fortune to charity. Please join me in welcoming Kiran to the panel. My next panelist is Professor Satyajit Mayer. He's an Indian cell biologist and currently directs a National Center for Biological Sciences at Tata Institute of Fundamental Research in Bangalore, India. Professor Mayer's lab aims at providing an understanding of the mechanisms behind cell membrane structure and organization and processes in metazoan cells. Don't understand most of that, so we can learn more about that. But Professor Mayer is a foreign member of National Academy of Science, fellow of EMBO, and has his PhD in life sciences from the Rockefeller University, New York, and lots of other accomplishments. My third panelist is Professor Siddhartha Mukherjee. You just heard him speak, famous for many things, including being the author of The Emperor of All Maladies, a biography of cancer, and the winner of the 2001 Pulitzer Prize in general nonfiction. Has his latest book, The Gene, An Intimate History, out, and it's a story of the quest to decipher the master code of instructions that makes and defines humans. He's an assistant professor of medicine at Columbia University and a cancer physician. We just heard about his work. A Rhodes Scholar. He graduated from Stanford University, University of Oxford, and Harvard Medical School. So again, very, very accomplished. And last but not the least, we have Sarv Saravanan here, a technology industry leader with more than 25 years of experience in incubating and scaling businesses, currently at Dell EMC. Saravanan drives the strategy and operations for centers of excellence and is responsible for research and development, product development, corporate IT, and more. He's worked at Microsoft before and many other places. And again, please join me in welcoming all the panelists to the stage again. So, as the topic suggests, we're going to talk about innovation ecosystems, and I think it's just worth starting off by saying that the growth of any economy or even a company is linked to the investment it makes in innovation. Clearly, no companies become a growth one by cost cutting, so it's important to talk about innovation in that context. And it's then no surprise that US, Europe, and Japan have really topped the table in regards to investment in innovation. And though China is fast catching up, India, unfortunately, has still a very, very small percentage of its GDP spend, less than 1% in R&D. And that's something that we absolutely need to change if we want to become a major superpower going forward. The latest economic survey of 2017-18 that was presented in the parliament talks about doubling national expense on R&D. And even though the spend has actually tripled in the last decade to about 85,000 crores, it still is a very small percentage of the GDP, as I mentioned. But what's more interesting is that private investments really lagged the investment made by the government, and still 77% of research is funded by government. Other interesting facts, only 26 Indian companies feature in the top 2,500 top R&D companies in the world, as compared to over 300 from China. And 19 of them, interestingly, are in pharma, auto, and software. I was surprised to hear about the amount of research happening in auto in India, for example. And just a little bit more on that, most of the spend, even the government spend, is from the center, very little state spend. But there are some positives emerging. I mean, the number of patents being filed from India are increasing, and India is today the 7th largest patent filing country in the world. The number of annual publications has gone up, and today India contributes over 4.5% of such publications, up from 3.1 a few years back. Zinov tells us that there are 650 MNCs with R&D facilities in India. So that's a sizable number from just a decade ago. And many of them are based out of Bangalore, as you know. And so that creates an ecosystem around us that even homegrown companies can tap into. But it's fair to say that the R&D landscape in India is evolutionary. And then there are clearly things we can do to change that, and that's what we're going to talk about today. So I'm going to start with Kiran, and clearly, when you started your business, Biocon, in 1978, it wasn't easy to go about building an R&D business. But do you think things have changed since then? And if a young entrepreneur would go about setting up an R&D business, have things changed significantly? And more importantly, have the public, academia, private partnership changed? Is that ecosystem more enabling for such a venture?
So let me answer that.
You might have to turn it on, Kiran. I think there's a button here.
Hello. Yeah. So let me answer that by saying that, well, in recent times, certainly there are some green shoots in terms of the way innovation and research-led businesses are taking shape. I would say that the other visible aspects are about incubators being set up at academic research institutions. So it clearly shows you that academic institutions are beginning to realize the importance of incubating innovative companies out of the research that's being pursued at their own research institute. So that's a very good sign, and I think Jitu here is an example of how that's happening at the National Center for Biological Sciences, where CCAMP, which is its incubator, is one of the best incubators in biosciences. But having said that, I would say that not too much has changed in terms of the amount that's being invested in research, especially in biological or bioscience-led companies. I know it's taken me a long time, 40 years, and I always considered myself a research-led company. And I know how difficult it has been over the years to get any kind of funding to back research. Even in the past, I know that even investors are not very friendly towards research-oriented companies. In fact, I myself have got crucified by investors and the investment climate in India, saying, why are you wasting money on research? That's the kind of questions I've been asked. So I think there is a clear dearth of understanding of why it is so important to invest in research if you really want to innovate and really participate in what's happening globally. You just heard Siddhartha Mukherjee talk about all the exciting things that's happening in cancer. And if you look at the last, comments he made on CAR-T technologies, after the US, the only country that's really investing big time in CAR-T is China. Why not India? India is doing really very little in investing in these kind of areas. So it clearly shows you that we are still very nascent in that approach of investing in research in a serious way. Yes, I think there are lots of very, very positive signals coming from some of these other tech areas. I think AI, data science, machine learning, no doubt there's a lot of very interesting work coming out of that. But when I look at our own field of biosciences, yes, there's some very smart research going on in some of our research labs, but not enough is translating into innovation because of lack of money, lack of funding.
Wonderful. And Kiran, as I was doing my research for this panel, I believe that Biocon spends about 10% of its
15.
15. So a big shout out there, round of applause as well. That's compared to the 0.7% we spend as a percentage of GDP. It's clearly remarkable. And most other large companies spend less than 1% based on my research as well. But let's shift gears, and we'll come back later to figure out what can be done to change that reality. So Professor Mayer, you're clearly part of an institute that stands for research, but how are institutions like TIFR playing a role in changing the innovation ecosystem in India, and what could be done more from the private sector to accelerate that innovation?
Well, I want to take off from where Kiran mentioned how NCBS, which is a TIFR center, how NCBS has sort of created a ecosystem for research and translation. And in a way, perhaps it's one of the first ecosystems for research and translation in the life sciences, exclusively devoted to the life sciences in India. And I must say, this was it took some doing. It took getting the Department of Atomic Energy, which is the primary funding structure of the TIFR, and the Department of Biotechnology, which is the funding agency for the Institute for Stem Cell and Regenerative Medicine that NCBS helped to incubate, to come together and say, look, we're putting all this research in one place. We really need to see how this can be translated into findings that could be taken towards building new products. And as Kiran also mentioned, the Center for Cell and Molecular Platforms was created about the same time to do precisely that. And that was a not-for-profit company which we decided would, take the resources that we had, which were for research, which were actually quite tremendous, and first of all, open them up to anybody who wanted to use them, including industry, and then bring in huge incubation possibilities. And so today we have about 40 companies incubating at CCAMP in a whole spectrum of things, from diagnostics to stem cell products to activities that relate to agriculture as well, and a lot of data science. So that's one strand. The other thing and I would have to argue this is sort of bottom-up, grown from the sense that since we, after 25 years of research, feel confident in our capacities to do something serious about our own research, we can take a step and create the possibility for incubation. The other side was actually somewhat of a top-down driven activity, which, and I just saw Ajay, there he is, hi. Ajay from Intel, where TIFR and Intel came together to partner in using AI for human-centric application. And here, of course, the life sciences is again a prime candidate for that kind of engagement. And that activity has been driven by both the scientific advisor to the Prime Minister and the Niti Aayog, and where in some ways it's a way of bringing in the research capabilities of a company based in Bangalore, with perhaps its highest focus on AI in the world, located in Bangalore, Intel, and partnering with the three sectors of TIFR, the life science sector, and the sector for that focuses on the monsoon, and their own focus on automobiles, creating hopefully a new ecosystem for building out new companies. So I think there's two ways to achieve this. One is bottom up and then reaching out. So we've also reached out to Kiran, and some of our discoveries are also being taken forward through collaborations with Kiran's company. So there are, I think these two things are what we are seeing happening now. I would have to argue, that unless you build deep research pockets, doing innovative science-led incubation or innovation is almost impossible, and you need to build it locally. And that would be sort of the way I see this. And none of these bottom-up or top-down efforts would have been possible otherwise.
And do you think the academic institutions have the bandwidth and the capacity to take on more?
Absolutely. I mean, I think if one gives them just gives them the rope, they won't go and hang themselves. They'll do something with it. Yeah, I think that's what we academic institutions. Well, ISC has been a good example. They're really pushing this, and one of the top completely genome-based life science companies has come out from ISC. Chandru's Strand Genomics is built out of ISC. So absolutely. Yeah.
Wonderful. Thank you. We'll come back more on that. So, Professor Mukherjee, let me just start by saying what inspires you about what you're seeing in India right now compared to perhaps when you were here, and then what can we learn from the West in regards to the private-public partnership?
Well, first of all, I mean, you have to realize that in the life sciences, translational research is very hard to do. Even everywhere, it's a struggle. But by translational research, I mean taking fundamental understanding of the natural sciences, the life sciences, and converting them into human therapeutics or human diagnostics or human prevention. This is a very, very difficult process, and you require an extraordinary ecosystem to be in place for this to happen across all disciplines, but especially in the life sciences, because these insights are often very difficult to get in the basic science arena, but to bring them from the basic science arena into human therapeutics takes an incredible amount of energy, work, and actually money. When I come back to India once a year, one thing that has become obvious is that slowly but surely that ecosystem is evolving in India. It is evolving. It evolved first I think in the genomics diagnostic space, partly because these are very data-heavy sciences, and because they're very data-heavy sciences, they exploited some of the natural talents that existed within India, within the Indian ecosystem. Then they moved on to chemistry, less data-heavy science, but also involving the capacity to manufacture at cost, often at low cost, things like biosimilars, things that have the capacity you can manufacture. And finally, they're moving into the biologics space where cell therapies, antibodies, and other biologics are now being deployed in the context of the life sciences in India. You have to understand that even in the best of places, which right now is the United States, this is a tough process. It requires, as I said, an incredible amount of dedication, incredible amount of money. The central thing, I think we focus, of course, a lot on money and in R&D, but the word that of course for a scientist, we make therapeutics. My laboratory makes therapeutics. There's only one word that matters, and it's called talent. There's only one word. You can pour money into a problem, and if you don't have talent, that money just leaks and gets wasted. There is just in translational research, and in fact in basic research as well, there is just one word. Infrastructure is the small word, talent is the big word. If you have talent and if you supply infrastructure, often money, it's not easy to find money, but money appears because it is a push rather than a pull system. And that is the most encouraging thing. That's the single most encouraging thing that you see in India, especially over multiple iterations. That the talent pool keeps increasing, it gets more sophisticated. It initially uses, and again, it uses what is available. When because data sciences was a natural arena, because there was natural talent in the data sciences, and because the capacity to store large amounts of data became quickly available, immediately it was deployed towards translational arenas. And those translational arenas could be very wide. It could be climate prediction, it could be agriculture, it could be genomics, it could be the life sciences. So now the question is, you know, there are new, as I showed you, there are whole new fields to identify likelihoods of someone responding to a drug, using genomics to drive drug therapy, and finally using cell therapies and other kinds of very advanced modalities. But the central force there is talent.
View on that, why don't we celebrate that more? Why don't we leverage that differently?
Yeah, we had to look back the incentive structure we created over the last 20, 25 years to promote the IT or IT services industry. If you peel the onion, the number of patents that get filed in India, about 80% of them are from the multinationals that do big business in India, the consumer technology companies like the Samsung and the Qualcomms. The patents that get filed in the USPTO from India are not from India-headquartered companies. It's all from the R&D companies that you just talked about. But they don't, you know, while there is indirect way of identifying where they come from, they are not attributed to India. And therefore, if you look at the Global Innovation Index, we are at the 66th position and way behind, you know, China and other countries. And I think there is a quick fix there for us, you know, just to change the perception that India is not a service delivery only country, but also a lot of innovation is happening. How do we accrue that to our credit? You know, the simple thing is that change the incentive structure. Just don't give, you know, any export is not necessarily should gain an incentive, but innovation-oriented investments. As you know, encourage the multinationals to file patents in India, patents of origin from India should be filed in India too, and give some incentive for that. And the second thing that I would say is, you know, look at what we need in the country in terms of capacity or capability to solve our own local problems, also be competitive in the, globally. There are lessons, there are enough lessons around the world. If you look at what's happening in China, in 2017, there was a comprehensive AI development plan for the country. Why did they do that? And, you know, they realized that they are the largest homogeneous market, therefore a lot of data. And second, they are losing their competitive advantage on manufacturing because of raising labor cost. And so how do we, how do they continue to be competitive? So therefore, AI became an important topic for them. So if you now look at, well, that is the paper, but actually, you know, a bunch of us went early this year to see what is real there, right? And there's a comprehensive plan at the central government level that gets percolated down. There's enough incentive the local governments, the provincial governments are creating to promote industries and ecosystem and incentives. And there is a lot of buzz there. And there is a BCG recent report that surveyed companies around the world. China really topped the list in real terms, and also went way ahead of there's a huge gap between US and China in terms of application of AI. And so therefore, and similar to that, what is that we need to do as a country to build capability for our long-term success or competitiveness? So what is the institutional framework that we can create? And there are a couple of things that come to mind. What led US to become dominant in science research? And there are some, of course, government spend money on the research. We are way behind on that. So can we increase that? And also, can we create, like Israel, can we create a symbiotic kind of setup here, encouraging multinationals to set up research centers and give them incentive, like I said earlier, and that creates capacity for us to make talent available for our startup to flourish at global scale. And the third thing is, I just recently heard that our CSR budget, based on the CSR Act, is about $3 billion. Not all of it is spent or spent well. And that is going to be 3 times more over the next few years. So what are we going to do with that money? Can we let these MNCs or Indian companies to invest in long-term research capabilities or capacity creation? I think those are some of the ways. We can't expect all the government to spend money on research like the US. Can we use these kind of vehicles to drive investment into long-term capability and innovation? Yeah. And I just want to tell you one more thing. Some of it, nice to hear Intel's and TFR work on AI. And recently, in the last several years, we have been spending money on building a platform for our public care delivery, a cloud platform, with, of course, analytics, machine learning, all of that built into it. And we are rolling it out across the country now. We don't get any CSR credit for it.
Okay. So I guess what we're hearing from our panelists is that things are improving, but there's a long way to go. So I'm going to do a quick round here, starting with you, Kiran. On your wish list, what could we do one thing differently to accelerate this innovation ecosystem? We heard about talent. We heard about more incentives. What's top of your list?
No, I really think we need a much better policy for investing in innovation, like Sarv just said. I think, we need a much better defined patent box regime. It's very suboptimal at the moment when you compare it to other countries. You need to have a much more serious intent to invest in academic R&D and encourage industry to also have much better incentives to invest in R&D. Which I think the government is making a big mistake because they keep on reducing the weighted average tax deduction on R&D investment. I think that is a big mistake we're making because science and technology is going to be the economic growth driver for India. And if we can't recognize that, then we are having a meaningless discussion. So I really believe that this is something which we must focus on. This is a forum and a platform where we are talking about technology diplomacy. It's about bringing technology and policy. And I think this is very important for us to make note of. And I, for one, believe that you've got to create a virtuous cycle of innovation if you really want it to become big. It's about academic research and private research and funding both. Government is funding a little bit, but I think we are not getting the traction for VC funding. And there's lots to be learned from other economies. If you look at the US, they have done it in the most optimal way. Even Europe has not done it the right way. So I really think we need to look at what the US is doing well. It has allowed huge investments in early stage startups. You look at the kind of companies who are able to list on NASDAQ, which is not really possible in India. We have too sort of besotted with a revenue model. So it's about the innovation and value creation model that we need to look at in a much more extensive way.
Kiran, you think something's holding back the VCs in that regard?
We don't have investing in value creation. That's it. We are constantly measuring companies by the immediate P&Ls. And that doesn't happen for startups. It's about value creation. What is the value creation potential of every startup? That's not being evaluated. So that's why you're not getting the VC funding the way it should happen. And that's the same mistake Europe has been making. So we should learn from that.
Thank you. Professor Mayer, how do we increase the number of PhDs coming out of India? Despite having such a large population, the number of PhDs is really, really small compared to the US, for example.
Right. Well, one is, of course, investment in research. So one incentivizes research and researchers and gets them to be connected to this entire chain that Kiran has just been talking about. That would be one way to get people excited about being able to just take ideas and bring them out into the innovation, incubation, startup ecosystem is actually a great way to incentivize researchers today. But if the pipeline looks like it's clogged at the end, you're not going to get enough people going into that space. So that's one way I would look at it. The other is to also bring out the local opportunities that we, I think, as often seem to forget. That India, the entire population structure of India, from the life sciences side, is an extraordinary opportunity for discovery. Right? So the population structure of India today is like hundreds of thousands of little mini populations, each of which doing their own experiments in all kinds of genetic traits that Siddhartha was talking about in his talk, where genes and genetics are easily mineable because we have an incredibly endogamous population. And if we are able to see that as an opportunity, and we have certainly the talent who can begin to exploit these opportunities. So bringing local questions into the fore and incentivizing researchers would be one way to change the game completely and build up a larger talent pool. I mean, and the last thing I want to say is that, if you look at this, the effort it took for us to put our ecosystem together, the NCBS, InSTEM, and CCAMP ecosystem has taken, let's say, 25 years. But if we cannot multiply that 100 times, then I would say that effort has been wasted. So we should be able to create these sorts of ecosystems now rather easily. The template is there, and we should be able to build that out very, very facilely today. Yeah.
Professor Mukherjee, you talked about talent. One last comment on what can we do to change the policy landscape, or what can we learn from the experiences in the West?
Well, actually, the experiences in the West are very important, but I think the experiences in China and Israel are actually also just as important. 20 years ago, no one had even heard of the talent pool in China, really. In the life sciences, if you looked at China, and to some extent at Israel, but certainly at China, it didn't configure in the landscape. It was an outsider in the landscape. In 15 years, that outsider in the landscape has leaped over in spectacular ways, sometimes, and we know about this, sometimes causing immense ethical concerns. Important separate question, but nonetheless leapfrogged over, and is now poised to exploit its talent pool. In the case of China, of course, this was very centralized. This was because of central planning. In the case of the United States, there was a mixture. It was a much more mixed model in which the government certainly put in money. Just remember, though, that the entire NIH budget is just $50 billion, 50-odd billion dollars, right? So it's not a giant. It is not a giant amount of money that the national.
So percentage-wise, it's not dramatically.
That's correct. But what happens is exactly what Kiran and Satyajit were talking about, which is that is the match that lights the fire. But to sustain the fire, you require an entire ecosystem to follow through, and that involves investments. That involves the natural development of an idea, which is often born in a laboratory, perhaps funded by the NIH, perhaps at the Rockefeller Institute, perhaps at Columbia University, perhaps wherever it might be, and it might be in diverse disciplines. It could be in the computer sciences, it could be elsewhere. But that is, once the flame is lit, it is carried forward really by, step by step, by hand, by different groups of people. Early investors who come in recognize the value of an idea, thereby allowing people to, form their first companies in garages around in Boston and New York and San Francisco. These cities have grown up around these ideas. Those are then moved across through investment, often early capital investment, early investment in training, talent, and recruitment. Often the recruitment comes from this country, where once the idea has been lit up, they acquire, recruit, again, further talent, and then is finally carried forward by complex markets which evaluate these products, allow them to become real human, allow them to add real human value. So again, I know the conversation is about ecosystem, but we have a lot to learn about these three ecosystems and their various advantages and disadvantages as we move forward. One very powerful thing to do would be to sit down and do a thoughtful cross-comparison between these three ecosystems, China, the United States, and Israel, to understand what allowed these, what were the advantages, how was each phase funded, what policy backgrounds enabled or disabled particular aspects of this to move from the one stage to the next stage, and where those are missing in the Indian context. I think that kind of analysis, you could certainly throw in Europe into this as well, into this equation as well, but that kind of analysis would really help us understand where the missing gaps are in every arena, particularly in the rapid growth industries, including, of course, the life sciences, data technologies, and AI, and other things such as robotics, automobiles, and other sciences as well.
No, I just want to add to that by saying it all starts with political will and political vision. I think if we as a country recognize science and technology to be our single biggest economic growth driver, I think all the policies will fall into place. I think you can see that we have a microcosm of this in this state and in Bangalore especially.
So do you see
And
this
therefore, I
state of
think,
Karnataka?
yes, absolutely. I think the kind of policies that we draw up for a state like Karnataka have always been path-breaking and something that the center finally has modeled its policies on. So I think there needs to be a much clearer focus on science and technology policy making, which I find, I'm sorry to say, at the center is not aligned with what's happening at many state levels.
Very good. Sir, any last comment before we open it up?
I would encourage, with some regulatory support, our research institutes and universities to be more entrepreneurial. The limited capacity we have on high-end research, whatever companies like us, as we approach them for any collaboration or joint research, it is as if they are doing us a favor. That's how the conversation goes. It's very hard to write a contract with them. And I think, if they are a little more entrepreneurial in terms of licensing and all of that, IP sharing, all of that, it'll go a long way. And the other part is also going back to what I said, encourage our large companies, CSR budgets to work with the universities to build capacity, long-term capability. I think that'll help us.
So
I also think we need a policy for allowing CSR spending in these kind of areas. By the way, there's not much clarity there.
It's a good call
So I think that's a very important policy enabler that should be actually looked at very seriously.
So I'm going to summarize. I think we've heard some really good suggestions here to accelerate and build this ecosystem. And we heard about policy at the center, but also in the context of CSR. Talent as a key differentiator and as a positive sign emerging, but more needs to be done there. VC funding and the notion of value-created funding, value creation mindset that drives the funding. And how do we carry the flame across the ecosystems? And in that context, analyzing US, China, Israel, and what's worked well, what hasn't, and a more entrepreneurial mindset within the academic institution. So with that, we'll open it up to questions. I know we're running late, so we'll just take a few questions from the audience. We have a few hands up. Can we get a mic there? The gentleman in white, please.
Thank you, Dr. Mukherjee.
Can you speak up, please, louder?
Thank you, Dr. Mukherjee. I have a question.
Introduce yourself, please.
My name is Karan, and I'm co-founder of iSenses Incorporation. We are a machine intelligence company. So I have a question about application of new imaging techniques, for example, multispectral or hyperspectral imaging for detection of benign and malignant tumors in mammary glands. And also because the traditional techniques are very inconvenient in terms of the discomfort level. And secondly, to you and Dr. Mayer, some new talks are going on, for example, relationship between telomeres and which is to aging, but also cancer. Can you please shed some light on it?
What was the second question?
Telomeres and cancer.
Telomeres in cancer. Telomeres, yes. So let me talk about the. I'll take a step back. I won't talk just about the multispectral imaging. I would have to. I actually had a few slides I skipped very quickly over. Again, this is an arena where you can see can be easily exploited in a country like India, because this is a very data-heavy field, and also requires a large patient population and requires some gold standard, a gold truth or a ground truth, right? So if you have a ground truth, a tumor is classified as benign or malignant by a pathologist. So you have a strong ground truth. You have a powerful data set that is behind it, which is the image itself. And then you apply various tools, whether they may be AI tools, whether they may be imaging, new kinds of imaging enabled by machine learning, etc. It's very ideally poised actually to be used because you don't require an enormous infrastructure. You don't require a bioreactor. You don't require a GMP facility to launch these kinds of projects. The only word of warning I have about this is, of course, is that because of the exact same reasons, this is a highly competitive field, among the most competitive field. We recently launched, actually I recently launched in collaboration with the Hutch, a project to read pathology specimens, prostate cancer pathology specimens, because as you know, with prostate cancer, it's very easy to read in the margins. You can very easily tell which patients are likely to do very badly and which patients are likely to do very well. It's the middle zone, which is very difficult because those patients, we don't know whether they'll do well or whether they'll do badly, and we can over-treat and under-treat based on that. The problem, as you can imagine, is that as soon as we launched this became it's an incredibly competitive space because it is the natural low-hanging fruit of the use of imaging and machine learning. So that's the one word of warning that I would have about this space in general. Jito, I'll let you take the telomere question, although maybe it might be too specific for this audience.
Well, yeah, I think that the question about telomeres is that, of course, their length does regulate the lifespan of a cell. So interfering with telomeres is a mechanism that cancer cells often adopt. But I'm not sure specifically what the question was, and perhaps it's best that we leave that for a post-panel discussion. But I just wanted to add something to what Siddharth said. There are huge opportunities for imaging-based applications in using the pathology databases in India.
Yes.
And
there, the ground truth is very strong.
Absolutely, and the network, and there's actually incredibly vibrant community of hospitals and hospital pathologists who are interested in getting involved. So corresponding, we've also engaged in a very large program on doing precisely that. It is a very competitive space, but one has to find a new angle to approach the imaging issues. And there are many, many questions, so I'll leave it at that.
Let's take a couple more quickly. This one right here in the front. I know we won't be able to get to everyone, so we'll have time after the session.
Hi, my name is Prasun Kumar. I'm from industry digital payments from Visa. My question is, are there success stories of industry-academia collaboration in open source, artificial intelligence, patent, and research paper? So one incident I would like to highlight just, so I asked, the patent people in my company, can we have, some people from Visa and some people from, my alma mater, right, in a patent filing? So they said, there are a lot of legal angles to it, so their answer is no right now, right? So has anyone of you achieved success in patent filing where some people from industry are involved, some people from academics are involved, and many more other things, right? So there are other things I want to know, how to improve internship experience of two months so that it is beneficial.
So we'll take the first
innovation.
one. I think the question's around, do we have any examples of patents being filed
Jointly?
jointly between academia
I
and
think
corporate?
patents can be filed jointly, but I think basically it all depends on where the patent originates from. I mean, if it originates from an academic lab, obviously then it gets licensed to industry. But if you're doing it as an industry academia partnership, as sponsored research, then obviously industry wants to have the patent, assigned to it. So I think that's really what we need to really look at in terms of how the patents are developed, how the agreements are around the patents, and where does it really originate from?
But it's possible.
Yeah, and in fact, we're exploring a new model. Can you hear me there? Yeah. So we're exploring a new model where we, in some ways, want to share risks with industry, and then there's joint filing, and these are parts of MOUs that we are signing as we speak with different sets of industries. And the first point that you raised about open source and products coming out of it, NCBS has actually pioneered an open source activity that today is perhaps one of the most common platforms for imaging. It's called Micromanager, no pun intended, but it's an open source platform for imaging that is available globally today. And we developed it along with some colleagues of ours, Ron Vale at UCSF. Yeah.
We're unfortunately out of time, so encourage those who have their hands up to meet the panelists outside. But please join me in thanking this group of speakers for joining us and sharing their thoughts. Thank you.
For the next talk, we have Dhiraj Rajaram, founder of Mu Sigma, to talk to us about the future of enterprise in a disruptive world.
Good afternoon, guys. Can you guys hear me? So they asked me to speak about the future of the enterprise in a world which is disrupting quite often. I've been a student of physics, and I've started enjoying physics even more when I didn't have to study it for exams. And, as I look at everything that we do in business today, we are seeing a world which can learn from the natural sciences quite a bit. We were in a world which operated, with lesser amount of entropy in the past. But today, the second law of thermodynamics is becoming more and more prevalent in everything that we do. The second law of thermodynamics basically states that entropy will constantly increase. What is entropy? The amount of disorder in the system. As I was listening to Dr. Mukherjee, talk about cancer research, I was just telling myself that many of these things hold good even for organizations. An idea, when it starts as an organism. And as it evolves, as more and more people acknowledge it, the market acknowledges it, it takes the shape of an organization. As it takes that shape of the organization, it loses its ability to explore. It loses its ability to make mistakes because the expectations out of an organization are quite high. And then you have large organizations which find it more and more difficult to thrive and find their organism. This is something that we are seeing constantly as we work with Fortune 500 companies. Let's look at the Fortune 500 today. You have the whole of Fortune 500, if you look at it, you can divide it into two parts. One, the network natives. Who are the network natives? People who are born into networks, born or acclimatize themselves well as networks. And these, the top 10 companies in Fortune 500 have about nearly 50% of the Fortune 500 market cap. And that's a phenomenon of networks. And the remaining ones are non-natives acclimatizing themselves to a world of networks. We had a world where everything that was physical became less physical. And that was done through software. And as that happened, you had, things could connect more and more easily. Friction was removed because software has less of friction. And because things are more and more connected, things took the shape of networks. Your taxi company is a network. Your hotel is a network. Your terrorist organization is a network. Everything in the world today takes the shape of networks. And in a world where everything is a network, if all problems take the shape of networks, then solutions must be interactions. I found it interesting that we still live in a world where we want, to protect our idea. The very nature of the idea is to flow. The new IP in a world of networks is not intellectual property, but interaction property. In that world, patents have no meaning. Trying to protect your idea, keeping it yours, and not allow it to go outside and really express itself fully will not allow you to get the most out of the idea. I feel that the thought process with which we have evolved our management thinking has come from a world of lower entropy. And all of those thought processes are today being challenged. You had a volatility and ambiguity that was moving with a certain pace in the past, and all management thinking was built to capture that. Today, we are operating with such high volatility and ambiguity, such high entropy, that the current ways of thinking about how we solve problems has to be relooked. So I want to make this a little real and show you one example from one of our customers. And Arjun, if you can just play that video for me, and I'll ask you to stop at a certain point.
THD's pro customers are largely remodelers, installers, and contractors for whom THD provides a dedicated pro services team. This team helps THD with multiple business aspects, primarily focusing on best-in-class service. This includes in-store experience, fast in, fast out, comprehensive assortment, and pricing strategies. One of the key initiatives as part of streamlining operations and serving the customers better is ProDesk transformation.
So I want to stop at this point of time and show you the internal of an organization. The internals of the organization is not one or two big problems, but many, 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 many small problems that are interacting with each other. Marketing is segmentation, recency, frequency, monetary analytics, customer lifetime value. Supply chain is inventory management, replenishment, collaborative planning, pricing. Supply chain and demand chain are more connected than ever today. And in such a world, we still operate with our silos of marketing people talking the marketing language, supply chain people talking the supply chain language, risk people talking the risk language, engineering people talking the engineering language, IT folks talking the IT language. And each of these silos have been beautifully created to become efficient. They were created so that an idea which was there could be exploited to the maximum. They were not created for a world where you will have higher entropy, where it is not just exploitation that is necessary, but you have to be in harmony of that exploitation with exploration. So for that to happen, the very nature of the organization must shift from this beautiful tree-based structure where you have a CEO, then you have 5 people reporting to him, and then you have another 5 people reporting to him, you have another 5 people reporting to him, to something that will help you solve for this problem space. This problem space walks every day at the management team, comes to the management team and laughs at them. Because it tells them, you can be nice and comfy in your organization structure, but we are going to express ourselves like this. And this means that more and more the organization has to become more horizontal. You will see that companies today are less industry-oriented and more horizontal, the companies of tomorrow. So our perspective was that when this problem came to us, and I just want to show you how this problem came to us. They basically said, look, we have a belief that we need to sell more to contractors. If you know Home Depot in the United States, it basically sells to people like you and me, and it also sells to contractors. And when you sell to contractors, they felt that they were not doing a good job. So they came up with this initiative. They had a catchy initiative, a catchy term for that. Marketing people generally do that. And they called it Own the Pro. And when they started looking at the problem space more and more, they understood that, when they started looking at it with its full complexity, okay, the world today is, if you are in this business of solving problems, you must be a student of complexity science. If you're not a student of complexity science and you don't understand how complexity manifests itself, you will land up solving only complex problems. You will not land up solving complexity as the problem. For that to happen, they needed to see that the problem space is all connected. And these people who were contractors were small business owners, they were entrepreneurs, and there was the power gap between them and a large organization like Home Depot was so high that if a Home Depot said, Home Depot decided to sell more and more to them, they might buy, but that might result in a place where some of them will go bankrupt because they might buy stuff that is not necessary for them. So from the relationship being Own the Pro, initiative being Own the Pro, they needed to be They needed to go to pro the own, which is professionalize the owner. So this change in thought needed them to see the problem space holistically, but also experience what is actually happening in the store. So you had to look at all kinds of data, and you had to look at data that is inside your enterprise, and data that is not inside your enterprise, and data that is not even there. So you had to create data. So that's the story that we are going to show as we continue the video.
Current ProDesk design is a bottleneck for the Pro customer's checkout experience and leads to a longer wait time. As part of the initiative, the ProDesks have been replaced by ProPods to facilitate speedy checkout and enhance customer service. These ProPods not only facilitate wait time and checkout time reduction, but also lead to better interaction with the customers. However, what is the challenge? To analyze the effectiveness of the ProPods, the team had to manually capture the wait times and checkout times due to the lack of data availability and infrastructure. To overcome the challenges from manual counting, MuSigma developed an innovative solution combining cutting-edge technology with the new deep learning algorithms in a low-cost setup. The solution has enabled us to process similar information efficiently and at scale. We captured videos for ProDesks and ProPods from different angles for the 3 test stores to capture customer point-of-sale metrics. A deep neural network model called Reinspect was used to detect humans from the video. This algorithm uses a recurrent LSTM layer for sequence generation. The model is trained to provide high accuracy for human detection with heavily overlapping instances. Since we only needed to detect the people who were making a purchase, we restricted our attention to an area of interest, namely the checkout counter, highlighted here in red. Additionally, the green areas represent a channel where people walk past the counter. After a human was detected, we leveraged the multiple hypothesis tracking algorithm to assign a unique identification number to an individual, which was then maintained while he or she moves in the designated area of interest. This enabled us to now measure the wait time and checkout time of each Pro customer without any manual intervention. Once this data was algorithmically extracted, it was used to understand variation in traffic and POS metrics over multiple days to validate the migration from desks to pods and to identify time slots that require further engagement from THD. As part of this solution, with the focus on scalability, we were able to successfully deploy an in-house IoT device prototyped in the Innovation and Development Lab of MuSigma in a city store to remotely record and store data without any manual intervention from our office at Bangalore, where the results were processed and validated. The results of our analysis stated that the wait time and the checkout time decreased by at least 11% and 12% respectively, which resulted in a decrease of at least 2 minutes in the net interaction time, and a significant improvement was observed in terms of the ease of the checkout process of the Pro customers. Building on the existing infrastructure, we can answer adjacent business questions in addition to analyzing wait times and checkout times. One such question could be maximizing impulse purchases, where we could analyze customer buying behavior to strategically plan the assortment at the checkout counter. Another avenue of interest might be addressing a staff optimization problem, where we can analyze peak hours in customer traffic to get insights that can help plan staffing better. There are numerous such instances where we can leverage the existing infrastructure to answer pertinent business questions.
So when you look at this problem, the way the problem manifested initially, the first question that the team asked was not the question that they eventually answered. So you had to, you have to give space for a theme that I call emergence, which is that you have to be accepting the discovery of your ignorance. Information is useful, and information is only useful if it can surprise you. If it cannot surprise you, information has less use. But we fight that surprise quite a bit. Why? Because we want to be proven right, because it's very comforting to be proven right. The world that we came from, the education systems that we came from, have tested us on coming up with the right answers. You take a test, you come up with the right answer, and you get better marks. You are never tested on asking better questions. So this perspective has led to a world where knowledge is revered. And in a world where knowledge is revered, it is very difficult to disorder knowledge. Learning is the disordering of knowledge. Learning is the rate of change of knowledge. And organizations who want to thrive with their organism in them will be learning-oriented rather than knowledge-oriented. They would be comfortable asking difficult questions. They would span over the horizontal, and they would interact with each other and come up with better questions and not try to answer the first question that is asked. If you are in a world of learning, then you cannot be dependent on experts. You have to be friendly towards experimentation. You have to be friendly towards making mistakes, and cost of making mistakes have to be brought low. We are in the business of helping people look good while fumbling. Can you create, if you are in a Fortune 500 company, you have to create an environment where you can look good while fumbling. And the last part is that don't try to keep secrets. And the new IP is not intellectual property, but interaction property. So with that perspective, I have about 3 to 5 minutes. So I'll allow you guys to ask a few questions, about how we think about how non-networks, how Fortune 500 companies who are not yet acclimatized into the network world can move to, being friendly in the world of networks. Yeah.
Thank you very much for your inspiring speech. Really enjoyed it. My name is Marian, Professor CMR, Bangalore University. My question is, what kind of competences you need to sustain the eagerness to learn, knowing on forehand, anticipating on, that you will disrupt current knowledge?
I think the future of education will again follow the same principle that it is not entities but interactions which are important. Which means that people have to learn. First of all, they have to be tested in groups. I don't like the fact that they are being tested individually. In education today, the first thing they teach you is that you cannot copy. Well, you should be allowed to copy and learn from each other and work as teams. The second perspective is that it's going to be interactions again, an interaction between a business analyst, an applied mathematician, and a programmer, interaction between art and science. Dr. Mukherjee talked about yin-yang. You're going to see yin-yang interactions of creativity and things that are chaotic, and technology, things which create order. So order and disorder will start interacting with each other. So I encourage people to learn like economics and computer science, or math and music. So those kind of interactions are going to become important. And I think it is about the individual being comfortable that it is he is not enough. And therefore, he must extend himself to the outside world and keep interacting. The problem with most things today is that the individual has been told that he should be complete, and that's the right word. That's the right way to live. If he can be comfortable with his incompleteness, then he can continuously extend himself and be learning-oriented. Yeah.
Hi, Dhiraj. Rich. Thank you for the great example about Home Depot. I represent Graminer. One of the questions I would like to ask you is, when you talked about, the starting point of the conversation was something else, but the conversation led to a different outcome as well as solutioning. One of the challenges we run into is when you approach a business with a solutioning, the cost comes into play, mindset comes into play, stakeholders trying to stick to what they wanted to find out comes into play. How, on this particular engagement, how is Mu Sigma tackling that piece?
I think we've encouraged all interactions with our customers to be in a way where we said that it's not just about solving specific problems, but actually more about the art of problem solving itself. Today's organization, and that's one of the reasons why we could scale this business, because we went with the perspective that we will not solve a specific problem for you. We are in the business of building this capability for you. And when we went with that perspective, we allowed ourselves, we bought ourselves the permission to look good while fumbling. So you have to get that permission. Unless you get that permission, you're going to be stuck inside the boundary that you drew for yourself, because they told you from the beginning to draw those boundaries. And subconsciously, you've been drawing boundaries throughout your life.
I'm Deepak Maheshwari. I work with Symantec cybersecurity company.
Sorry, I'm not able to hear you.
I work with Symantec cybersecurity company. Symantec.
Okay.
So my question is, you mentioned about the patents and other things being open, and Mu Sigma itself has patents, for example.
Yeah.
So what's your policy in terms of opening up that and how that is being used? Can you give some examples around that?
First of all, we have a lot of trademarks. Very little to do with patenting. And I kind of fight with my management team quite a bit, but they don't listen to me. That's the problem of operating as networks. Having said that, one of the themes through which we have interacted with our customers is that anything and everything we learned from the customer's data belongs to the customer. You decide what you want to do with it. I think the future of networks is going to be governed by trust. Okay? And you have to create speed, and speed can happen only through trust. And you have to create an ecosystem of vulnerability. And that ecosystem of vulnerability happens when you're not trying to possess the whole insight yourself. The whole product mentality, to some extent, is about learning once and then automating forever. That became very, very popular because some VC told you that if you have a product, then you will get better valuation. So instead of focusing on value, you focused on valuation. And that's how products have become more and more and more interesting. I think the future is one where products and services will be in harmony with each other. And the people who recognize that fact will actually build more value than valuation. So my perspective is that the whole enterprise of the future, not today, will operate with 3 simple equations. The first one in physics is speed is distance divided by time. So you have to operate, if you want to operate with more speed, you have to cover more distance and you have to do it in less time. The second equation in physics again is velocity is speed with direction. Now, throughout your life, you have been told as a child that please make sure that you are going in the right direction and then you go fast, right? But in a world of high entropy, you'll have to make a lot of mistakes. And therefore, in this new world, you have to operate where cover a little distance, make your mistake really, really fast, and then focus on direction. So in this new world of networks, distance becomes more interesting than direction for some time, after which direction becomes more interesting than distance. And the last equation from physics is momentum is mass into velocity. And for you to have momentum, you need to scale, and scale cannot happen without engineering. So there are 2 pieces. One is emergence, the other piece is engineering. Emergence for exploring really, really well, and engineering for exploiting really, really well. Again, a yin-yang perspective. things have to operate as paradoxes. You yourself have to become that paradox, and you have to be comfortable being a paradox. So that's how I would think about it.
Thank you so much. For the next panel to talk to us about the changing world of digital payments, could I please request on stage Anubrata Biswas, Airtel Payments Bank, Aparna Krishnan, Mechanism Labs, Malavika Raghavan, Dwara Trust, Nikhil Kumar, iSpirit, and Vindu Goel, The New York Times.
Welcome, everyone. Thank you for joining our panel on digital payments in India. First thing I'd like to do is, actually, I know we're all about digital payments, but I'd like to ask the audience, how many of you prefer to do cash payments, cash transactions? I see just a couple of hands. You are very unlike your countrymen. 85% of transactions in India are still done in cash. That's one of the challenges that India is facing. I come from the United States. I moved here about a year ago, and I could go 1 month by withdrawing $100 in cash from my bank account, and at the end of the month, I'd still have like 60 of it still left in my wallet because everything's digital, and India's a completely different place. So I wanted to start by asking each of our panelists a question. And I want to start with Malavika, who studies digital payments. How are Indians using digital payments now? Why are we still at 85% cash?
Can you hear me now? Yes, perfect. There, so much for technology. So yeah, I think a little bit of background in terms of what my organization does. Many of you in the room will know IFMR, who are now called Dwara. And about 10 years, we've been working on financial inclusion. And really, if financial inclusion is such a big challenge, how can technology actually come in there and solve this challenge? It's the first use case for many of our big government projects, so I won't say more about that. But we're seeing, in terms of digital payments themselves, the recipient, the user of this digital payment in India is very different from the user anywhere else in the world. It's a massive market. But just to put some context around that question that Bindu asked, and if only so few of you use digital payments, the mainstream consumer in India, the kind of people that we care about in our work, which is someone from a low-income household in India, there's about 70% of us are rural, and of that 70%, about, I think, across the board, 100% of India, over 77% of us are from a household that makes less than rupees 10,000 a month. And what does that mean for digital payments? It really means that we're looking at majority of the population who's going to be making very small value but high volume transactions. And how is that kind of panning out? I think that's how that's panning out is, I think, the consumer in India is really, if you're thinking about digital payments, mobile first. We know for a fact that there are over 1 billion mobile phone subscriptions in the country, and 96% of internet usage in this country is over mobile. And that's only going up and up. We only have about 27% of Indians who are on the internet, which many would say is required for digital payments. We have, of course, USSD payments, but we can talk about that later. And if that is the case, if only 27% has access to the internet, how is that going to change in the next 5 or 10 years? And we think, this is the big, like Kleiner-Perkins-May-Remika report, we think that usage of the internet is growing something like 9-fold year on year. Indians, those who have access are using something like 1.5 GB of internet per, those who have access are using a lot. So last year, the year before, it was only 0.3 GB or something. And now suddenly you're seeing this meteoric rise in internet usage to people who have access. So the question really becomes, when it comes to digital payments, is this making a difference? And actually the last kind of number I leave you with, and maybe we can talk about this more, is 86%, I think you mentioned is the number of cash transactions. The latest figures from the RBI that we have as of, I think, October, November 2018, it's still over 19 billion rupees that is currency in circulation. And only about 2.9 billion is actually a digital payment. So I think there's something here that we need to think about, is that who is the market that the digital payment players are focusing on? And actually, if we need to get to a larger section of the pie, then what is the model we need to be thinking of? Is it a kind of cash plus digital model? Do we need to be playing to the fact that actually the majority of our population, at least for the foreseeable future, is still heavy cash, but also getting access to technology? So there needs to be some kind of interplay between these two. And those are the kind of questions I'd be curious to talk about on this panel.
One of the successes of digital payments in the last few years has been the rise of UPI, this system that allows you essentially to make a payment person to person to anyone. And Nikhil, you were really involved in the creation of UPI and the popularization of UPI. Why did UPI work? What has been successful about it? Do you see it continuing to be adopted, or is there sort of a new permutation that we're going to see of this kind of payment?
Yeah, so, as Malikwa said, context, India had a number of fragmented digital payment systems till couple of years ago. You had ATM-based digital transactions that people conduct. You had people using mobile banking from banks, which is powered by IMPS. And then there was the card ecosystem, which is how globally most payment systems have evolved, including US, which is completely cashless, as you said. In India, unfortunately, the problem was that even though the Jan Dhan Yojana brought in millions of people into the banking ecosystem, it didn't bring them onto the digital banking ecosystem. So the first step, the way bank accounts became more useful for a lot of people in the society, is that you started holding money in these bank accounts. Digital payment is just a mode of accessing this money, right? You could access this money digitally using an ATM. You could access this money using a card. Now, what we're talking about UPI is, how do you access this money using a mobile phone? And so UPI is built on this premise that every Indian will have a mobile phone. The Jan Dhan Yojana has already covered almost universal banking. Everyone today has a bank account. So why UPI is special is not because of the technology. It's special because of the philosophy behind UPI. The philosophy behind UPI is that India as a country needs a low cost, high volume, low value payment system. And if this needs to be achieved, and that is the only way, the way we achieve this is by riding on devices that already exist with people. So this could be feature phones or smartphones. And the idea of having an interoperable payment system. All around the world, if you look at payment systems, especially in mobile payment systems that have evolved, most of these mobile payment systems are all closed loop payment systems. What that means is, if I'm using app A, if I have to send money to you, you need to be on app B too, app A. So I can't send money, say, from an Alipay to a WeChat. Alipay and WeChat are the ones who showed the world the power of mobile payments, but unfortunately, they're all closed-loop payment systems. The idea of UPI was to build an open, interoperable payment systems that brings all different stakeholders together to innovate for the consumer. It brought the banks onto a common technology specification and a platform. On the other side, you have a number of companies which are now building amazing customer experiences, both for consumers and merchants alike, and building a lot of innovation on top of it. So UPI is special largely because of its design philosophy, got to do less with the technology. There are enough of technology tools for everybody to use to get something built like UPI, but the idea of UPI is more about building an interoperable payment system. And this design philosophy has led to these network effects, which is why in the last 18 months, UPI has been the fastest growing public payments platform in the world. Just in last month, we did $12 billion and 520 million transactions a month just from 18 months of launch. So with this, India is now the largest playground for digital payments around the world. And all around the world, there are countries which are looking at UPI and trying to learn from it on how do they build similar equivalent payment systems for their countries to enable financial inclusion.
Another tool that the government has used to increase financial inclusion is the creation of this new category of banks called payment banks. And I have to confess, sort of in traditional economics, banks make most of their money by loaning out money to people and charging interest, and a payments bank can't do that. I would love to ask, in that context, Anubrata, can you explain to us what a payments bank is, what the niche is, and why, or how it is that you're going to be able to make money if you can't make loans? Especially with these UPI transaction costs so low, you can't really charge much for UPI.
Yeah, so look, India has roughly 5 big problems, which UPI addresses to a little bit, but not yet fully. And let me just call out those problems and then sort of articulate what the thought process on the policy side was to really get this going. The first problem is that we've still got 190 million underbanked Indians. 48% of the country's bank accounts are inactive. Inactive defined as never used. So a large proportion of the Jan Dhan Yojana accounts have actually never been used or accessed. The second big problem really is that there are 13 million small Kirana stores which are not digital and have never been digital in any form. And quickly running through the rest 3, there are 30 million small businesses which are not paying taxes and which really employ a large unorganized workforce. There is a 3.5% insurance penetration in the country, and informal credit markets are roughly double the size of formal credit. Now, we have to ask ourselves a question, this is the 21st century, why are we at this point where we are? And really the answer is extremely simple, it boils down to unit economics. Traditional banks and the banking industry has evolved a model in the country where they have a cost of delivery of service to the retail customer of 4,000 rupees per customer per year. Just to highlight this in the context of the income, banks, typically well-run banks would make a little more, poorly run banks would make a little less, but they generate 6,000 rupees of income. So there's a 75% cost to income on the retail banking side. But if you look at the supply side of the equation, which is the underbanked, there's no way on earth a poor customer will ever generate 6,000 rupees of income. And that's why there are precisely 137,000 bank branches in the country. Bank branches have not gone beyond certain points, certain locations, certain districts. And really the onus is for policy to recognize this and think and encourage industry to come out with models which are thinking in hundreds of rupees as opposed to thousands of rupees. So regulators really attacked the problem from 2 ends of the spectrum. They gave licenses called small finance banks, which were really very well-established microfinance institutions who were really deep in distribution, and said, look, you've already got the customer on the asset side, why don't you just convert them into liability so that they can get used to basic banking transactions? And the other end of the spectrum was large corporate houses who had extremely large distribution and extremely large customer bases, and therefore very low unit economics of customer operation. Why don't you just go ahead and offer basic banking services? And the real hope is that a large proportion of this 200 million underbanked will really come on board. So to put this in context, Airtel today has 1.3 million banking points, which is roughly 10 times the banking distribution of the country. And there is access to customers of roughly around 340 million customers. In terms of size and scale, Airtel Payment Bank operates at an annualized payments flow of roughly $8 billion. And there are 30 million customers, of which 6 million are using the bank every month. So just to again put it in context, Kotak Bank would be at around 10 million customers in their lifetime. So there's extreme scale which needs to be built up and which is getting built up. And as the unit economics play out, the real hope is that we will deliver firmly the two agendas of financial inclusion and digital leadership.
Okay, but how are you going to make money if you, that small customer isn't going to generate the 6,000 rupees? You know, how do you make all those banking points profitable?
So as we were discussing last night, if you analyze traditional bank P&Ls, roughly 40% and 20%, right? Let me repeat the numbers, 40, 40, 20. 40% of a bank's income today in the country comes from pure income out of deposits. 40% of the bank's income comes from income on lending, and 20% of the bank's income comes from cross-sell, service charges, and transaction fees. Now, if you really put this in context of the capital which is invested in the banking sector, the only income stream which you really don't have access to is the middle 40%. But what you really do have access to is a very broad base of customers which you can refer on to other lenders using a platform which you build up, using the data which you get about the customers, for example, who are getting credits regularly, who are withdrawing regularly, and who are therefore coming into formal banking. So in my view, the final income model of payment banks will look as 40, 30, 30, 40% coming from deposit income, 30% coming from referral income, which is really income out of loans and insurance, and 30% out of transactions and service charge and fee income. And to quickly jump into how that 30% of fee is really going to come from, Malvika pointed out that there's $90 billion of cash which flow in the country every month. Every single cash exchange today actually is friction and therefore is an income opportunity. And there's a vast amount of opportunity in really using the Airtel distribution to offer access for deposits, for withdrawals, not just by consumers, but also by institutions, and therefore generate income. So very simply, instead of 40, 40, 20, it's going to be 40, 30, 30. There's absolutely no reason why you should not make standard economic profits basis a reasonable amount of capital which you will invest for the long haul. In my view, given that you need to build scale first in order to generate unit economics, you will be at one end of the spectrum from small finance banks who are starting with an asset P&L and therefore will become profitable much faster. Does that answer the question?
Yeah, absolutely. It seems hard to think about the blockchain in finance in India when what we started out this conversation about was cash and how much people are using cash. But Aparna studies the blockchain in finance. And so I'm really curious, what role do you see for blockchain technology in Indian financial transactions? Like, will we all be paying each other in Bitcoin or some kind of virtual currency?
I'm definitely curious to see if that happens, not with the current crypto regulations, it seems. But quick show of hands, how many of you here kind of understand what a blockchain is?
Everyone.
Okay, great. We're all on the same page.
That's the issue.
So I definitely think that blockchains could have various different roles in the Indian payment ecosystem. So one really interesting role that Bitcoin has recently been having is in Venezuela, where the peso has been hyperinflating. People are now paying each other in Bitcoin. So maybe in like rural areas where people are still paying each other in barter system or have no ability to be part of any global financial services, the blockchain can provide them some sort of financial inclusion. And what's really interesting is blockchain could be a great way for people to crowdfund. So maybe like get loans to start up their small businesses and take risk on the blockchain, all with your reputation put up to the rest of the world. These are several different use cases which I think blockchain could enable. Another really interesting point which Nikhil brought up about the UPI, with you having WeChat Pay and now you have like WhatsApp Pay, all of these different paying options that you have. How do you pay across options? Well, if you have a global currency, all of a sudden you could do that. If you had like an Indian blockchain rupee coin, all you had to do is like in the UPI plug that in, and WhatsApp Pay uses that, Google Pay uses that, everyone just pays each other with this kind of currency. And I think another really interesting thing about blockchain is it can enable these micropayments. So up until now, payment systems are managed because there's someone who's like a middleman who takes a cut in most payment supply chains.
You're referring to the 30%.
Yes, exactly. But for example, if you had this technology which was not owned by anyone, but they build this technology for free because their Bitcoin appreciates over time, the more people use it, then you no longer have this problem of having to take a cut in the middle. Instead, you can enable new kinds of payments which are micropayments. And why are micropayments interesting? Well, all of a sudden, you can change incentives in society. So maybe you can now have like a trash can which pays people every time you pick up trash and put it in the right part of the trash can. Other things you could do is like pay someone who is acting well on the street. And other really interesting things with the blockchain enables is you can pay inanimate objects. So what that means is like this water bottle could now be paid, or a piece of land could now hold cash if you can represent that as a smart contract. And all of this opens up completely new possibilities of payments. What you could do with it, well, if you had a community that was trying to clean a river, and they can't get the government to come in and clean that river, they could just crowdsource within themselves and pay this smart contract or pay the river, which is represented by the smart contract, and once it gets cleaned, the contractor gets paid out. And all of these different things you probably couldn't do without the blockchain.
Wait, okay, my brain is melting here. Explain to me, like, let's say we have this problem, right? The Ganga is filthy, and they've been trying to clean it up forever and ever and ever, pretty much unsuccessfully. So how could the blockchain be used to pay the Ganga to clean itself up?
Well, you wouldn't pay the Ganga to clean itself up, but what you could do is a group of people maybe who are living around the Ganga are saying, well, it affects my everyday life and I want this to be cleaned. So let's all send money to this object called a smart contract, which is a digital representation of Ganga. So now Ganga has an online
like a
persona.
digital collection bin or something, a donation bucket or something.
Exactly.
Okay.
But no one owns this donation bucket, which is what makes it a bucket that everyone's okay sending their money to. If any single person owned this bucket, you might feel like, what if they took my money and they ran away with it? So all of a sudden, you can set a due date by which, if not enough money is in the bucket, whoever paid the bucket gets paid back. And if there's enough money in the bucket, a contractor gets paid to do the cleaning of Ganga.
Huh. That's interesting.
Which is...
That sounds like an idea that somebody should try.
we can already do that if there was no regulation. Yes.
Well, if the government would trust you to set up cryptocurrency donation, I think there's a little skepticism in the Indian government about cryptocurrencies. I think they're talking about a total ban. Right now, you can't trade them. And I think that sort of raises a bigger question. Certainly in my conversations with people around India, when I've been talking to people about why they don't make digital transactions, it seems like there's a trust factor. They don't trust that the money will be there. They'll put it into some digital wallet or digital bank account. Airtel, I'm sad to say, had its issues before your tenure, but where it was opening bank accounts without clear permission from people, and some of their government subsidy payments were going into accounts really without their knowledge. And that kind of thing doesn't help build public confidence in digital payments. I'll sort of throw this open to the panel, but is there something that needs to be done to sort of get people to trust that their money would work, that would be there digitally, and that they could really use these transactions?
I could just set context.
Yeah.
I think a large part of this issue is a design problem. I don't think it's a digital versus physical problem. I think it's about how do you build trustworthy digital experiences. Unfortunately, as everyone, as you pointed out, this is not the real India, right? Real India never comes to a conference. A lot of digital products that have been built for Indian consumers have always been following Western design principles of minimalism, material design, and so on. So I don't think we as a community understand the depth of this problem. We don't have icon sets. We have 22 official languages. There are so many dialects. 1 million people speak different languages in India. So like, for example, the Chinese don't have to deal with this problem because 90% of people, everyone speaks Mandarin. So we have a big design problem in India, and the design problem is how do you build digital experiences for customers? And this is just not about financial, digital payments at all. How do people understand what a shopping cart is when they've never shopped in a supermarket ever, right? So you have a design problem for Indian consumers, and this is partly to blame is the entrepreneur ecosystem or the technology ecosystem, is because all of us are running behind this 50 to 100 million consumers, who are like the cream of India, and you're trying to monetize by building digital products for these customers. So more and more, as we start thinking about how do we enable the next 100, 500, a billion people into digital products, we have to look at this as a design problem. And the reason I say this is because it's not that, look at ATMs, right? You could argue we could be sitting 10 years or 15 years here in the same place early, and we could be talking about how people are not using ATMs because it's frictional. There's so much of friction. How can you bank with a machine? This is something that was unheard of. My parents are rural bankers, and for 35 years I've seen, in the last 28 years, I have seen how people have started adopting different methods of digital payments in rural Karnataka, and in ATMs at the same issue. So it's a user experience design problem. Unfortunately, a lot of our design principles are all imported from the West, and as everybody would agree on the panel, India is very different from every other country. So we have to start thinking and designing from first principles perspective. So I don't think there's the digital versus physical trust problem. It's largely a design problem, and I hope that many of us in the audience and others will solve for it in the coming years.
So I have a thought, right? And if you permit.
Sure.
So I completely agree, and I'd quickly like to add 3 things, right? First is an analogy, right? And the analogy is really between, if you look at 5,000, 7,000 years back, agriculture first spread really rapidly in Europe. And that's primarily because Europe is a latitudinal continent. So weather ranges are broadly similar across a wide land area. And so agriculture spread extremely fast from Iran to the left. Whereas if you look at South America, it's a latitudinal continent, and therefore there are very different types of crops which came up at very different spaces within that continent. it's exactly the same thing between China and India. If you take the two variables of literacy and language, you know, you have a fundamental contrast of 76% versus 100% and 22 versus 1. And that's why for each of the areas of India, you need specific investments. So I'd just like to add to what Nikhil said, while yes, it is a design problem, I think as players in the policy environment in the country, I think we have to ask ourselves, what is in it for private capital? Why should somebody come and put in money to design a great experience for somebody in Andhra Pradesh in a rural area if there's no money to be made at the end of it? And that is where I think broadly, while the market has developed a brilliant, and I would go out so far as to say the best public payments infrastructure in the world, it's still, I would say, a little archaic because pricing is capped and fixed. And therefore, you see only payment players building scale who don't have payments as a fundamental end use case. They have something else they want to do with it. So you see an Amazon, you see a Google, you see a, you know, you name anyone
WhatsApp,
else, you know,
Microsoft,
WhatsApp,
everyone is in
they all
India.
want to do something else with that. But payments for the sake of payments, which has really two things, the digital adoption, and before that the cost of education, and the cost of education is the higher element of cost actually. Private players are really not keen to take on a state-wise basis. And that's where national players like us, we believe, come in as a payment bank because you're almost a fintech. You can operate with scale. You've already got the distribution infrastructure. And so with a limited amount of capital, you can make experiments. But from a policy point of view, I'd strongly encourage pricing to be fully free and for the markets to decide what it wants, because you know there may be pockets of excellence which could develop.
Malvika, do you agree with that? Is it a pricing and design problem?
I was just going to say, gentlemen, can I come in to this conversation? Actually, I have 3 points. I actually do agree on the pricing. At a substantive level, I do think the pricing and transaction costs in the country is quite messed up, and we need to look into that. But I think the kind of background question, and 2 questions that both Nikhil and Anubrata brought up. I mean, one thing you were saying is what's in it for private capital. And I do agree, it has to be a product proposition. There has to be a pie which is worth serving. Having said that, though, I think there are many cautionary tales in countries which have basically let the market set the terms of payment infrastructure development. I'm thinking mostly in terms of, say, Kenya, which is always thought of as the kind of success story for digital payments because of M-Pesa and M-Shwari, I mean the credit.
Not anymore.
Not anymore, for reasons we should talk about actually. Because essentially what happened there is that you have a private MNO that is providing the pipes for digital payments in a sense. And that was, the market solution worked for a while until the point where you get a monopoly in terms of that private MNO. And then you see that any of the surplus that the companies are generating, whether that's the banks in the back end, the MNO itself, or any service providers, are not translating into consumer surplus in competition law terms, right? There's that welfare surplus gap is not being met. It's sticking at the level of private capital. So clearly when there is something for private capital, they come in and of course they do very well in terms of service. Now what's the flip side of this? And this is where I want to bring India in. The flip side is then you're really doing payments for the sake of payments. And my interest in this, and as someone who speaks to policymakers and studies regulatory theory, digital payments are a means to an end. We don't do digital payments or raise volumes for the sake of it. We might if we're running a digital payments enterprise. But actually our interest is in how can we use this as a way to bring people into the formal system, and how can we actually do financial depth for the system itself. So you really need to be thinking about bringing people in safely, not in a Kenya kind of way. And I kind of, apologies to any Kenyans or people in the room, but essentially what then happened is you have people who are held to ransom by a particular type of system. There isn't really a payment switch. A private MNO is doing a large part of your basically value of GDP transactions.
And the same is with China with 90% with two companies.
Yeah, exactly. And then what happens is you have all these issues around stability, depositor protection. There is no depositor protection in these accounts, for instance. And then, of course, lastly, the Mshwari story, which is these payments were then used, the transaction trail there, the data of the consumers was used to give out small ticket loans. Many of you would have used like credit products like Ola Credit, which we've been talking about. Except that when people thought it was a 100 shilling loan and they just didn't, it's a mobile top up. They say you need more cash, here's a loan, top it up, pay us back. And it's within 3 or 4 keystrokes, you've done that. And if you don't then repay that loan and you default, you just think, oh, it's 100 shillings, it's not a big deal. That gets reported to the credit bureaus. And this really came up, I think there were about 400,000 Kenyans who were blacklisted from credit, which is a real problem stability-wise. That's bad for both the banks and for the consumer. And that number is going up and up. So obviously that's a scenario we don't want to get to. But I think the two things it does talk about is it brings us to the question of, how should digital payments work? And actually what's the role in terms of our payments infrastructure of our government institutions? Because India does have one of the best payments infrastructure, but correct me if I'm wrong, since the 90s, a lot of this, I'm not normally a person to always bat for RBI regulation and its elegance, but I do think that they led a lot of this, right? The national payment switch, NEFT, RTGS, a lot of this was, because there was basically a drive in terms of setting up the playing field for people to come in and play. And that's the balance we want to get to. I think on the pricing issue, we've gone too far, where we're not paring back from that playing field and let the market set. But I really think there's a conversation about where should private capital play, and where there's a market failure or there's the private capital ignoring a part of the market, really what can we be doing, not just as government, but as people involved in the regulatory and kind of inclusion space, what can we be doing to bring those consumers in? Because you can't just say it's financial literacy or digital literacy is going to solve the problem. People are using these phones. That same report basically says, the Kleiner-Perkins report, it says people are using 1.5 GB data, but 45% of that is on entertainment, another 45% or 50% is on kind of messaging. Only 2% of that is actually on finance. So clearly, the trust barrier we were talking about, there's something here about people are using phones, but I don't think mobile equals
generally,
finance.
Digital payment requires very less amount of data. When we were doing this with WhatsApp during one of the conversations, it's actually lesser data to send a digital payment instruction than actually send you a forward message or an image on WhatsApp. So which is why the cost argument is, in this new world that we are living in, when both are connected in their own devices, both are paying for their own internet bills, what are you charging for? So when you look at it from a work done principle, high cost for digital payments in the mobile era doesn't make sense. I also just wanted to add to...
Can I just ask there, Nikhil, but my concern there is like we're saying mobile equals usage, finance usage. It's kind of the same bank account equals finance problem, right?
No. I completely agree. I think, internet usage is somewhere here and mobile digital payments usage is somewhere here. So, someday this bridge will gap. But the jury is still out, so we have still more time to go. But I'm an eternal optimist. But I also want to kind of, give a little bit of context of India's digital payment infrastructure. A lot of us have been focused on just talking about peer-to-peer payments and peer-to-merchant payment network. But India has actually a lot more. And because digital payments is just not, there are different contexts in which you use digital payments. You all might know there is NEFT and RTGS. This is run by the RBI, which is a batch-based digital payments system where you can send money from bank account A to B. IMPS is a mobile payment system. This was launched by NPCI in 2010. US still doesn't have this after 9 years of we launching IMPS. And then we have what is called as the Aadhaar Payments Bridge, which is basically the ability for any institution, especially government institution, to send money to a bank account using the national ID, which is the Aadhaar number, which is what is being used for DBT. We have the Aadhaar-enabled payment system, which is basically an ability for a customer who has his Aadhaar linked to his bank account to withdraw his money from an ATM or a micro ATM or a branch. We have UPI, which is the Unified Payments Interface, which is a mobile-first payments infrastructure. We have RuPay, which is the world's lowest cost card-based payment system. Even within RuPay, we have something called RuPay Q Spark, which is an interoperable digital payment system for fast payments in metros and bus stations and so on. We also have the Bharat Bill Payment System, which is an interoperable bill payment system, which enables anybody to pay, an Airtel Recharge and Airtel Mobile on any other app, or whether pay your electricity bill or water bill. And finally, we have what's called as the FASTag, which is the NETC, which enables you to have a sticker on your car and zoom past a highway toll gate. So digital payments is not, when you think about digital payments infrastructure, it's just not about enabling payments between two people. It's about enabling payments between entities. Entities could be people, institutions, government, private, and so on. So as Anubrata is saying, the idea of digital payments is to basically think about it as roads, and you need to now build businesses and build trade on top of it, right? Which is nothing but micropayments, using micropayments to enable better lending for people, using micropayments to enable better insurance, using micropayments to enable better savings behavior, and so on. So like I was saying just before the panel, I think Indian digital payments infrastructure can be best described as, if you think about it from a test match perspective, we have won the toss, the conditions are looking great, and we are just, getting started. So we're just getting started, and I think we have a long way to go, but, the pitch looks promising.
Yeah.
Except for today.
Since we have such a digitally payment savvy crowd over here, I'd love to take a few questions from the audience. This gentleman up here has been eager for a while to ask a question.
Just
sir.
two brief points, sir. We have made a tremendous technological progress, but just recently we had a fraud in the Punjab National Bank to the extent of 13,000 crores. Why could technology prevent this happening? Point number two, I have a newspaper cutting of Deccan Herald dated 26th November, wherein it is mentioned that Assistant General Manager of Baroda Bank is a fairly senior functionary in the nationalized bank, and he is well versed with all the things. But he has found that 1.70 lakhs has been withdrawn from his account, and he had taken all precautionary measures. Despite that, this fraud has taken place. How do such things happen? Thank you.
Aparna, you should say why it won't happen.
It sounds like a
blockchain
type of solution.
Well, I guess these are examples where you don't necessarily have to trust a bank, or you don't necessarily have to trust an individual. These are situations where blockchain, of course, makes sense. So one thing which the blockchain enables, and this is actually becoming a trend in America, is to have custodial wallets. What that means is you have complete control of your public-private key, and you manage how and when you join this payment system and when you leave this payment system. No one else can control or prevent you from entering. No one else can prevent you from joining. It's basically like storing all your cash under your pillow, as long as you're able to control this digital wallet and like you're able to carry it around with you wherever you go. But that's one like new trend that's happening. But again, I think we do have banks and we do have a lot of central institutions because it makes things easier. For people who don't fundamentally trust these institutions, you should have other options. But I think if you're willing to trust these institutions, like Coinbase is the biggest exchange.
Yeah.
It holds your public-private keys. It holds your access into this financial system called a blockchain, which is decentralized. It provides you huge efficiency in return for doing that. So,
can I just quickly also add? I mean, given that hopefully for India that will be a while before we get there. I think.
Yeah.
I think one easy kind of, they call it, what is it in policy school, $20 bill problem. Like it's lying on the floor. Why has no one picked it up? I think the answer to your question, sir, from a regulatory perspective, I think a design problem is a liability framework issue in our country. In the US, when an unauthorized transaction happens on a bank account, the bank has liability until, like, automatic putting the consumer back in the money until that issue is solved. In our country, we have basically no liability for banks for unauthorized transactions. Last year, the Reserve Bank brought in limited liability when there's an unauthorized card just a card transaction. So only for people, of that split of who have credit or debit cards, if there's an unauthorized transaction. But even for that, you have to report the unauthorized transaction within 3 days for the bank to pick up the tab. So in this situation, there's basically no incentive for a bank to invest more than what is absolutely required in security. Because if they lose the money, it's not on them, right? Or any NBFC. And I think the concern here is that you're disintermediating the market. And all these new types of small companies coming in who are not even banks. If there's not a crazy, like a nice, light, agile, incentive-based liability framework, we're going to have some trouble like this, I think.
I just want to extend the question to Anubrata. If I keep my money in Airtel Payments bank account and a fraud happens, what happens?
So, that's why I really love the regulators for coming up with this license. For us, liability is always capped at 1 lakh because bank account limits can't go beyond 1 lakh. We'd be very happy to refund you.
Oh, great.
Right? Having said that, I want to address one very basic point which many people in the course of time tend to miss. If you look at early 90s, right? Say 1998 and onwards, the number is very startlingly clear. There has been 10% market share movement every 10 years from public sector banks to private sector banks. So today the market share of private banks stands at 28% and the public sector bank is around 72%. 20 years back it was actually 8%. We have to recognize that just as much as it is an exercise in technology, it is also a phenomenal exercise in change management at public sector banks to adopt technology, come up to the same standards, and therefore move up the curve.
Let's take another question from the audience. I think this young lady over here has been was the second one who had a hand up, so thank you.
Thanks. My name's Tanvi. I'm a blockchain lead at EY, and my question is for Aparna. So I'm quite active right now for the last few months with the key regulators in India on crypto policy. And the key concern here is around capital flight, really. If you enable cryptocurrencies, a lot of money leaves India. And more importantly, it's an existential threat, right, to the banking institutions, to monetary policy. So what are your thoughts on that? Have you seen good arguments against that?
Yeah, so this is a great question. And I think, so one really popular kind of cryptocurrency that's getting adoption in America is called USDC, which is a stable coin. So to break that down, it basically means there's this company called Circle, which issues a cryptocurrency, but they control the supply and demand of it. So they still use the blockchain for all of its other benefits, which means anyone can be part of the system, join and leave. But they pretty much control any kind of illegal activities from happening because they control the spending and the transactions. They also pretty much control the pricing of this cryptocurrency. So it's not like Bitcoin. It's not like the price is shooting up one day and crashing the next. So this could be an interesting option for the Indian government if they want to issue a stable coin, which they control the supply and demand of. And then there are definitely ways of using that stable coin and still having other properties of the blockchain in that it being decentralized and such through complicated algorithms which you can add on top of that. Yeah.
Can I just, so when you say something like that, then basically what you're talking about is not a payment system, but a new asset class, which can be enabled, which can be plugged into any existing payment system, right? So essentially you're talking about a new type of a stored value account, which is different from my savings account or my mobile wallet. So is there a thin line that blockchain walks around versus being a stored value account versus a payment system?
Yeah, so this is a great question. A lot of people currently use Bitcoin as a store of value. And I think so far, the biggest use case that blockchain payments have found is as a store of value. In fact, Bitcoin is called digital gold. And the reason is because it's a secure and good store of value if you're able to control the volatility. In terms of if it's going to be a good medium of exchange, that is yet to be seen. Currently, there exist a lot of frictions with respect to like fees. Your current mediums of exchange are probably like more frictionless to use right now. So like you said about UPI.
Safe to say Bitcoin is a bank account killer and not a bank killer.
Yes.
Is it a fiat killer? That's my question. Is it killing fiat?
Is it a
Central bank?
fiat killer? I don't think so yet, because for example, Bitcoin itself is so volatile. If you make a payment in Bitcoin and the value of it goes down, the other person doesn't want to even receive Bitcoin anymore.
So we won't see this digital gold of Bitcoin replacing gold in the Indian weddings anytime soon. I'm sorry, we're out of time. I see a lot of other questions. I think that all the panelists will be around sort of after our session. If you have questions for anybody individually, we'd be happy to try to answer them. And I really appreciate the level of interest from everybody in the audience. And thank you very much for tuning in today.
Thank you. Thank you so much.
Thank you so much. I know in the agenda we had a coffee break, but we'd have to go right into the next panel. Given the rapid pace of artificial intelligence advancements, Shivnath Thukral, Facebook, and Manish Sabharwal, team leads.